Have you ever truly listened to the night sky? Not the sound of the wind rustling through the leaves of a nearby tree, nor the distant, rhythmic hum of a city that never sleeps. I mean the sky itself, the vast yawning gulf that begins just a few miles above your head. We are creatures born into a world of constant, unrelenting noise. Every second of our lives, we are bathed in vibrations. Oxygen, nitrogen, and carbon dioxide act as a medium, a cosmic fabric that carries the laughter of a child, the roar of an engine, and the whisper of a secret. Our very biology is tuned to this symphony. Our ears are delicate instruments designed to catch the ripples in the air. We define our reality through these echoes. We feel safe because we can hear the world around us. But once you cross that thin, fragile, and translucent line of our atmospheric blue veil, so delicate it seems like a miracle, the universe changes fundamentally. It doesn't just become quiet in the way a library or a deserted street is quiet. It becomes absolute. It becomes a silence so heavy that it feels like a physical weight against your skin. In the vacuum of space, there is no air to vibrate. There is no medium to carry the screams of a dying star or the silent collision of two galaxies. You could witness the birth of a supernova, an explosion so violent it outshines entire solar systems, and it would happen in a total, terrifying, and majestic silence. This is the first and perhaps most haunting truth of the universe. It is a place of immense, incomprehensible power, yet it remains fundamentally indifferent to our presence. It does not speak to us. It does not listen. It simply exists, vast and cold, stretching out into an infinity that our minds were never designed to truly grasp. But as we look deeper into this silence, something even more unsettling begins to emerge from the darkness. There are places in the cosmos where the silence isn't just a lack of sound. It is a lack of everything. There are regions where the very fabric of space seems to have been stretched so thin that even light itself seems to lose its way, wandering through an endless corridor of nothingness. Imagine, for a moment, that you are floating in the exact center of one of these places. You are suspended in a void so immense that it defies calculation. You look to your left, and there is only blackness. You look to your right, and the blackness continues, unbroken and perfect. You look up, down, behind you, it doesn't matter. There are no stars to guide you. There are no galaxies to remind you that life exists. There is no hope of rescue because there is no one to hear your call and nowhere for your signal to go. Scientists have a name for these cosmic deserts. They call them voids, and the largest one we have ever discovered, the Boötes Void, is currently challenging every single law we thought we understood about the birth and the architecture of the universe. To understand why the Boötes Void is so terrifying, we must first look at our own home. We live in a crowded, bustling neighborhood of the cosmos. Our galaxy, the Milky Way, is not a lonely wanderer. It is part of the local group, a tightly knit cluster of at least 54 galaxies, all bound together by the invisible, ghostly fingers of gravity. When we point our most powerful telescopes toward the stars, we don't see chaos. We see a magnificent, intricate structure known as the cosmic web. Imagine vast, glowing filaments of dark matter and hydrogen gas, stretching across billions of light years like a spider's web woven by a god. These filaments are the highways of the universe. They are where the action happens. Galaxies flow along these lines like droplets of water on a wire, clustering together in great cosmic cities where stars are born in the millions. This structure gives us a sense of comfort. It suggests that there is an order to the madness. It suggests that the universe has a design, a skeleton that holds everything in place. But as our technology has advanced, as we moved from the grainy lenses of the past to the legendary clarity of the Hubble, and now to the revolutionary infrared eyes of the James Webb Space Telescope, we have been forced to confront a much darker reality. The stuff of the universe, the bright stars we wish upon, the swirling planets we hope to visit, the colorful nebula that capture our imagination, all of it is the exception. The void is the rule. The universe is not a collection of things. It is a collection of empty spaces, occasionally interrupted by the presence of matter. According to the Lambda CDM model, which is our current gold standard for understanding the Big Bang, the universe began as an impossibly hot, impossibly dense soup of particles. As the universe underwent a period of rapid inflation and began its multi-billion-year expansion, tiny, microscopic fluctuations in density began to take hold. Gravity, the most patient force in existence, began to pull matter together in the areas that were just slightly denser than others. Over eons, this process created the web we see today. However, gravity is a greedy, exclusionary force. As it pulls matter into clusters and filaments, it leaves behind the spaces between them, like bubbles forming in a loaf of baking bread. These voids grow larger and emptier as the universe expands. Most voids are modest in size, perhaps 30 to 300 million light-years across. Within them, you might find a few lonely, isolated galaxies, scattered like grains of dust in an abandoned mansion, forgotten by the rest of the cosmos. But then, there is the anomaly, the place where the math of the Big Bang begins to fail. Located approximately 700 million light-years away from our pale blue dot, in the direction of the constellation Boötes, lies a region of space that simply should not be there. It is known officially as the Boötes Void, but those who study it often refer to it by a more haunting title, the Great Nothing. To truly grasp the scale of this emptiness, you have to let go of human measurements. Miles and kilometers are useless here. Even the distance between planets is too small to serve as a yardstick. Imagine a sphere of absolute emptiness so vast that it spans 330 million light-years in diameter. To put that into perspective, the Milky Way is about 100,000 light-years across. You could fit thousands upon thousands of galaxies the size of our own inside this void, and they would still be lost in the darkness. If you were to place the Milky Way in the very heart of the Boötes Void, our night sky would be a terrifying sight. We are used to seeing a band of light across the sky, the glowing arms of our galaxy, and the distant glint of other star systems. But in the center of the Great Nothing, you would look out and see a wall of impenetrable, perfect blackness. For millions of years of travel in any direction, there would be nothing but the vacuum. Astronomer Robert Kirshner and his team, who first stumbled upon this hole in the universe in 1981, were deeply shaken by the discovery. It wasn't just that it was empty, it was that it was too empty. According to our most advanced computer simulations of the Big Bang, there hasn't been enough time in the 13.8 billion years of the universe's history for a gap of this magnitude to form through gravity alone. It is a cosmic impossibility, a scar on the face of reality that we cannot explain. Consider the sheer scale of the loneliness involved. The distance between us and our nearest major neighbor, the Andromeda Galaxy, is roughly 2.5 million light-years. In that relatively small gap, there is constant gravitational interaction, a dance of stars and gas that will eventually lead to our two galaxies merging. Now, try to imagine a space that is 130 times larger than that gap, and finding absolutely nothing. If our ancestors had evolved on a planet in the center of the Boötes Void, our scientific progress would have been stunted for centuries. We would have believed, with absolute certainty, that we were the only island of light in an infinite, dead ocean. We would have had no reason to believe that other galaxies existed. We would not have discovered the expansion of the universe until the middle of the 20th century. Our entire philosophy of existence would have been built on the foundation of being utterly, completely alone. If the Boötes Void is the ultimate cosmic desert, then the rest of the universe should be a blooming garden. We have established that the Great Nothing is an anomaly, a scar on the architecture of reality. But when we turn our eyes away from that hollow abyss and look toward the rest of the cosmos, toward the dense, shimmering filaments of the cosmic web, we are confronted with a second, perhaps even more terrifying silence. This is not the silence of a place where nothing exists. This is the silence of a place that should be teeming with life, yet remains as quiet as a tomb. This is the heart of the Fermi paradox, a question so simple it haunted the mind of one of the greatest physicists in history, Enrico Fermi. During a lunch in 1950, he looked at his colleagues and asked a question that has defined our search for the stars ever since. Where is everybody? To understand the gravity of this question, we have to look at the numbers. The sheer scale of the opportunity for life in our own Milky Way galaxy is staggering. There are at least 100 billion stars in our galaxy alone. Some estimates push that number closer to 400 billion. Current astronomical data from missions like Kepler suggest that almost every star has at least one planet orbiting it. Many of these stars are billions of years older than our Sun. If life follows the same patterns elsewhere that it did here on Earth, then the universe should be overflowing with civilizations. There should be radio signals crisscrossing the vacuum. There should be massive engineering projects, Dyson spheres, or stellar engines visible to our infrared telescopes. By all accounts of probability, the Milky Way should be a bustling, noisy metropolis of intelligence. And yet, we sit here on our small, blue marble, broadcasting our existence into an infinite, unresponsive dark. This brings us to one of the most sobering concepts in all of science, the Great Filter. Imagine that the development of life is not a straight path, but an obstacle course of cosmic proportions. To go from a collection of simple chemicals in a warm pond to a spacefaring civilization, a species must pass through a series of gates. These are the filters. It begins with the jump from non-living matter to the first self-replicating cell. Then comes the transition from simple cells to complex, multicellular organisms. Then, the development of a brain capable of abstract thought, the use of tools, and eventually, the mastery of nuclear energy in spaceflight. The Great Filter theory suggests that one of these gates is nearly impossible to pass. It is a wall that almost every civilization hits and shatters against. The terrifying question for humanity is, where is the filter? Is it behind us? Perhaps the jump from single-celled life to complex life is so rare that it has only happened once in the history of the galaxy. If that is true, then we are the lucky survivors of a cosmic lottery, the only light in a universe of darkness. But there is a darker possibility. What if the filter is still ahead of us? What if every civilization, once it reaches a certain level of technological power, inevitably destroys itself, whether through nuclear war, climate collapse, or the creation of an artificial intelligence it cannot control? The filter might be waiting for us in our near future. In this view, the silence we hear from the stars is the silence of billions of dead civilizations that failed their final test. But what if the silence isn't caused by death? What if the silence is a choice? This leads us into the darkest corner of speculative science, the dark forest theory, first popularized by the visionary writer Liu Cixin. This theory suggests that the universe is not an empty graveyard, but a crowded, predatory jungle. Imagine a forest at night. It is pitch black, and the air is thick with the sounds of insects and the rustle of leaves. In this forest, there are hunters. These hunters move with absolute stealth, their footsteps silent on the moss, their weapons drawn and ready. These hunters are civilizations. In this dark forest, the most basic law of survival is suspicion. Because the distances between stars are so vast, and the chain of suspicion is so long, you can never truly know the intentions of another civilization. You cannot know if they are peaceful or hostile. You cannot even know if their definition of peace matches yours. If you encounter another life form, you must assume they are a potential threat to your own survival. In a universe where resources are finite and life is constantly expanding, any other intelligence is a competitor. Therefore, the only logical, self-preserving move for any advanced civilization is to stay hidden, to remain perfectly silent. And if they happen to detect another civilization that is foolish enough to reveal its location like a child shouting in a forest full of tigers, they must eliminate that threat immediately, before it has a chance to grow and become a danger. If the dark forest theory is the reality of our cosmos, then humanity has been incredibly reckless. For over a century, we have been broadcasting our presence to the universe through radio waves, television signals, and deep space probes. We are the child in the forest, shouting at the top of our lungs, unaware of the hunters who may be closing in from the shadows. The silence we hear from the stars isn't because no one is there, it's because everyone else is too smart to speak. They are listening, they are watching, and they are waiting to see if we are a threat that needs to be silenced. Consider the implications of this for our search for extraterrestrial intelligence. We have spent decades pointing our radio telescopes at distant suns, hoping for a hello. But in a dark forest universe, a hello is a death sentence. This theory suggests that the most advanced civilizations, the ones that have survived for millions of years, are the ones that have mastered the art of being invisible. They don't build massive glowing structures. They don't send out signals. They exist in the cracks of the universe, observing the younger, louder species like us with a cold, calculated indifference. The Boötes Void itself, which we discussed earlier, takes on a new, sinister light under this theory. Is it truly a natural void? Or is it a sector of the galaxy that was cleared by a supreme predator? A place where the lights were turned out long ago to ensure that no new competitors could ever arise. As we contemplate the Fermi paradox and the dark forest, we realize that the silence of the universe is not a neutral fact. It is a heavy, pregnant silence. It is a silence that demands an explanation. Whether we are alone because we are the first, alone because everyone else is dead, or alone because everyone else is hiding in terror. The result is the same. We are on our own. We are a solitary flame flickering in a storm of infinite blackness. And as our technology advances, as we begin to peer into the very dawn of time with the James Webb Telescope, we are starting to realize that the rules of this game might be even stranger than we ever dared to dream. While we contemplate the existential weight of the dark forest and the crushing silence of the Fermi paradox, our own technology has recently begun to whisper back at us, but it is not whispering the answers we expected. Instead, it is telling us that our very foundation, the mathematical house we have built to explain the universe, might be built on sand. For decades, we believed we had the timeline of the universe mostly figured out. We had the Big Bang, a period of rapid inflation, the cooling of the cosmos, and the slow gravitational clumping of gas into the first stars and galaxies. It was a neat, orderly progression that spanned 13.8 billion years. But in July 2022, a golden eye opened in the darkness of the L2 Lagrange point, and everything changed. The James Webb Space Telescope was designed to be a time machine, because light takes time to travel across the vast reaches of space. Looking further into the distance is quite literally looking further back into the past. Webb's massive gold-plated mirrors were tuned to capture infrared light, the stretched out, ancient echoes of the very first stars that ignited in the cosmic dawn. We expected to see babies. We expected to find small, chaotic, and disorganized clumps of stars that were just beginning to find their gravitational footing. We expected a universe that was immature, dim, and slowly finding its shape. Instead, the images that flashed across the screens at NASA and the European Space Agency sent a cold shiver through the scientific community. Deep in the earliest reaches of time, only a few 100 million years after the Big Bang, Webb found giants. It discovered mature, massive galaxies that shouldn't have had enough time to grow. In the standard model of cosmology, it takes billions of years of gravitational interactions for a galaxy to reach the size and complexity of our Milky Way. Yet, here they were, shining bright and fully formed, existing at a time when the universe was only 3% of its current age. Astronomers have begun to call them universe breakers. They are an impossibility. To find a fully developed, massive galaxy so close to the Big Bang is like walking into an empty field where a forest was supposed to grow in 1,000 years, and finding a 300-foot oak tree standing in the center. This discovery has forced us to ask uncomfortable questions. Is the universe much older than we thought? If the universe is actually 20 or even 30 billion years old, it would give these galaxies the time they need to evolve. But that would mean our measurements of the expansion of space, our very yardstick for the age of the cosmos, is wrong. Or, perhaps, matter didn't clump together slowly. Perhaps in the early universe, gravity worked differently. Or dark matter was much more aggressive, pulling stars together with a ferocity we have never observed in the modern era. We are currently witnessing a crisis in cosmology, a moment where the data from our most advanced instrument is directly contradicting the textbooks we have used for half a century. This crisis is deepened by a second, equally baffling mystery known as the Hubble tension. We have known since the time of Edwin Hubble that the universe is expanding. Galaxies are flying away from us, and the further away they are, the faster they go. The rate of this expansion is called the Hubble constant. For years, we have used two primary ways to measure it. The first is to look at the afterglow of the Big Bang, the cosmic microwave background, radiation that fills every corner of the sky. This gives us a measurement of how fast the universe was expanding shortly after its birth. The second way is to measure the distance to nearby stars, like Cepheid variables and supernova, to see how fast the universe is expanding now. In a logical, predictable universe, these two measurements should match. They should tell the same story. But they don't. The measurement from the early universe tells us one speed, while the measurement from the modern universe tells us another, significantly faster speed. For a long time, scientists hoped this was just a human error, a mistake in the calibration of our telescopes, or a misunderstanding of the dust between stars. But James Webb has now confirmed the discrepancy with unprecedented precision. The tension is real. The two ends of time are disagreeing with each other. What does this mean for us? It suggests that there is a missing piece of the puzzle of new physics that we have yet to discover. Perhaps dark energy, the mysterious force that is pushing the universe apart, isn't constant. Perhaps it is changing its strength over time, accelerating the expansion in a way that our current equations cannot predict. Or perhaps there is a hidden form of radiation, a dark radiation, that influenced the early universe in ways we are only now beginning to suspect. We are standing at the edge of a scientific revolution, staring into a gap in our knowledge that is as wide as the Boötes Void itself. Consider the humbling nature of this moment. We are the most technologically advanced version of humanity to ever exist. We have sent probes to the edge of the solar system. We have mapped the human genome, and we have captured the first images of black holes. And yet, when we look at the most basic questions, how old is the universe? How fast is it growing? What is it made of? We find ourselves more confused than ever. The James Webb Space Telescope was supposed to provide the final answers, the missing links of our cosmic history. Instead, it has shown us that the universe is far more complex, far more ancient, and far more mysterious than our small, human minds ever dared to imagine. As we drift further into the darkness, moving past these universe breakers and into the unknown future, we realize that the silence of the cosmos isn't just a lack of sound. It is a language we haven't learned to speak yet. The anomalies we see are not errors in the universe. They are hints that the reality we perceive is only the surface of a much deeper, much stranger ocean. And as we prepare to face the ultimate fate of this expanding, mysterious machine, the final fading of the light, we must hold on to the curiosity that brought us here in the first place. For in a universe that seems determined to break our rules, the only thing we can truly count on is our will to keep looking. We have spent much of our journey looking backward, peering into the ancient voids of Boötes, questioning the silence of the Fermi paradox, and marveling at the impossible galaxies discovered by the James Webb Space Telescope. But to truly understand the scale of the cosmos, we must now turn our gaze in the opposite direction. We must look forward, far beyond the lifespan of our Sun, beyond the collision of the Milky Way and Andromeda, into a future so distant that the very concept of time begins to lose its meaning. We are heading toward the ultimate fate of all things, a destination that the laws of thermodynamics tell us is unavoidable. We are heading toward the heat death of the universe. It is a common misconception to think of the end of the world as a violent explosion or a sudden dramatic collapse. In the vast, expanding theater of the cosmos, the end is not a bang. It is a slow, agonizingly quiet fade into nothingness. It is the victory of entropy, the physical law that states that in every system, energy tends to spread out, to dissipate, and to move from order into chaos. Imagine a cup of hot coffee sitting in a cold room. Over time, the heat from the coffee spreads out into the air until the coffee and the room are the same temperature. There is no longer a difference that can be used to do work. The universe is that cup of coffee, and the room it is sitting in is an infinite, expanding void. As the universe continues to expand at an accelerating rate, pushed by the invisible, ghostly hand of dark energy, the distances between galaxies will become so vast that even light will be unable to bridge the gap. In about 100 billion years, every galaxy beyond our own local group will have vanished behind a cosmic horizon. If there are astronomers living on a planet in our galaxy, then they will look at the sky and see only the stars of our merged Milky Way and Andromeda. They will find no evidence that other galaxies ever existed. The universe will literally shrink in their eyes, becoming a solitary island of light in a sea of absolute, uncrossable blackness. The great cosmic web that we see today, with its glowing filaments and bustling clusters, will have been torn apart, molecule by molecule, by the expansion of space itself. But the fading doesn't stop there. Stars, the great engines of the universe, have a finite supply of fuel. One by one, the massive blue giants will explode as supernova. The medium-sized stars, like our own sun, will swell into red giants and then collapse into white dwarfs. Eventually, only the smallest, most patient stars will remain, the red dwarfs. These stars can burn for trillions of years, sipping their hydrogen fuel with a desperate, lingering persistence. But even they have an end. Trillions of years from now, the last red dwarf will flicker and go out, like a candle in a drafty hallway. This marks the beginning of the degenerate era. The universe will be a graveyard of stellar remnants, black dwarfs, neutron stars, and cold, dead planets drifting through a darkness that no longer knows the warmth of a sun. In this era, gravity, the very force that built the galaxies, becomes a scavenger. Over spans of time so long that a trillion years feels like a single second, the remnants of stars will either be ejected into the void or swallowed by the ultimate titans of the dark, black holes. We now enter the black hole era. For an inconceivable amount of time, black holes will be the only significant objects left in the cosmos. They will grow to monstrous sizes, consuming the last scraps of matter until there is nothing left to eat. They will be the kings of a dead empire. Yet, even black holes are not eternal. As Stephen Hawking famously predicted, black holes leak. Through a process known as Hawking radiation, they slowly, almost imperceptibly, lose mass over time. For a supermassive black hole, this process takes a period of time that the human mind cannot even begin to visualize a number, followed by nearly 100 zeros. But eventually, the math wins. The black holes will begin to evaporate. In their final moments, they will vanish in a faint, pathetic pop of gamma rays, leaving behind nothing but a thin mist of subatomic particles. Now, we reach the final stage, the dark era. The universe has reached its maximum state of entropy. There are no stars, no black holes, no heat, and no light. The temperature of the entire cosmos has dropped to just a fraction above absolute zero. The particles that remain are so far apart that they will never meet again. Time, for all practical purposes, has ceased to function because nothing ever happens. There is no change, no movement, no life. There is only the same perfect, terrifying, and infinite silence that existed before the first star was ever born. The universe has become a cold, dark, and empty room that will never be occupied again. When we contemplate this future, it is easy to succumb to a sense of nihilism. If the ultimate destination of all things is a cold, dead void, then what is the point of the journey? Why do we build? Why do we love? Why do we struggle to understand the stars if the stars themselves are destined to vanish? But perhaps the answer lies in the very fact that we can ask these questions. We are a brief, brilliant flash of lightning in a very long night. We live in the only moment of cosmic history where life, light, and complexity are possible. We are the witnesses to the universe's greatest act. Our existence isn't a mistake. It is a miracle of timing. The fact that we are here now, a time when the galaxies are still close enough to see, when the stars are still burning, and when the mysteries are still fresh, is a gift of staggering proportions. We are the atoms of dead stars that have developed the ability to think about the end of time. We are the universe's way of reflecting on its own mortality. And while the coming dark is inevitable, it only serves to make the light we have right now more precious. The silence of the future is a reminder to value the noise of the present. Every scientific discovery we make, every footprint of knowledge we leave behind, is a victory against the encroaching shadow. As we navigate the vast, silent stretches of the Boötes Void and peer into the terminal darkness of the heat death, we are forced to confront a humbling, almost embarrassing truth about our place in the universe. Everything we have ever seen, every star that has ever burned, every galaxy that the James Webb Telescope has ever captured, every planet, every mountain, every human being, all of it is a mere fraction of what actually exists. We are, quite literally, living in a universe that is mostly invisible to us. Scientists now know that normal matter, the stuff made of atoms, the stuff that we are made of, accounts for only about 5% of the total energy and matter in the universe. The other 95% is composed of two mysterious, ghostly entities, dark matter and dark energy. Imagine you are at a grand, celestial ball. You see the dancers, the stars and galaxies twirling across the floor in a beautiful, synchronized dance. But as you watch them, you realize they are moving far too fast. According to the laws of gravity discovered by Newton and refined by Einstein, the galaxies should be flying apart. There isn't enough visible matter to hold them together. It's as if they are being held by invisible partners, dancers who cast no shadow and reflect no light. This is dark matter. It is the invisible scaffolding of the universe. It doesn't emit radiation, it doesn't absorb light, and it doesn't collide with normal matter. It only interacts through gravity. Without this ghostly substance, the Milky Way would have disintegrated eons ago. We wouldn't exist, because the stars would never have had the gravitational glue needed to form into galaxies. We are, in a very real sense, guests in a house built by something we cannot see. For decades, we have searched for the identity of dark matter. We have built detectors deep underground in abandoned mines, shielded by miles of rock to catch the faint, subatomic whispers of weakly interacting massive particles. We have crashed atoms together in the Large Hadron Collider, at nearly the speed of light, hoping to recreate the conditions of the Big Bang and glimpse a particle of the dark. And yet, the silence remains. Dark matter refuses to reveal its face. It remains a mathematical necessity, a shadow that we can measure but never touch. It is the silent architect of the cosmic web, the dark filaments that connect the islands of light across the void. But if dark matter is the glue that holds the universe together, then dark energy is the force that is determined to tear it apart. Discovered in the late 1990s by observing distant supernova, dark energy is perhaps the most profound mystery in all of science. It is not matter at all, but a property of space itself. It is a repulsive force, a cosmic anti-gravity that is pushing the galaxies away from each other at an ever-increasing rate. While gravity tries to pull things inward, dark energy acts like a relentless pressure, inflating the fabric of space faster and faster as time goes on. The strangest thing about dark energy is that it doesn't get diluted as space expands. When a gas expands, it becomes thinner, but as space creates more space, there is more dark energy. It is as if the universe is a balloon that is being blown up, not from the outside, but by the air that is being created inside the rubber itself. This is the force that will eventually lead us to the heat death we discussed earlier. It is the driver of the expansion that will one day push the Boötes Void into an even greater emptiness. It is the reason why the future of the cosmos is not a collapse, but a permanent, lonely isolation. Consider the James Webb Space Telescope once again, sitting in the cold, silent shadows of the L2 point. It is 1,000,000 miles away from Earth, looking into the infrared dark. It is searching for the light of the first stars, but in doing so, it is also mapping the influence of these dark ghosts. By observing how the earliest galaxies are distributed, Webb is helping us understand the battle between dark matter's pull and dark energy's push. It is a war of the invisible, a struggle for the very fate of the universe that began at the moment of the Big Bang and will continue until the last star flickers out. We often think of ourselves as the masters of our domain because we can name the stars and calculate the orbits of the planets. But we are actually like sailors on a vast, dark ocean, clinging to a tiny, glowing raft. We can see the foam on the waves, but we have no idea how deep the water goes or what creatures lurk in the depths. Dark matter and dark energy are the ocean. We are just the foam. This realization doesn't diminish our importance. Rather, it highlights our courage. We are a 5% species trying to solve a 100% mystery. We are using our small biological brains to decode a universe that is mostly hidden from our senses. This is the true footprint of knowledge. It is the act of looking into the dark and refusing to look away. It is the willingness to admit that we don't know, while never stopping the search for the answer. As we look at the maps of the cosmic web, and we see those vast, empty voids like boats, we now understand that they aren't truly empty. They are filled with the silent pressure of dark energy. They are the battlegrounds where the future of the cosmos is being decided. And we, for this brief, miraculous moment in time, are the ones who get to watch the struggle unfold. If the existence of dark matter and dark energy makes us feel like strangers in our own universe, then the next step in our journey will make us feel like a single grain of sand on an infinite beach. We have spent this hour discussing the universe as if it were a single contained entity, a solitary bubble of space and time that began with a big bang and will end in a heat death. But what if that bubble is not alone? What if the footprint of our reality is just one of many, scattered across a landscape so vast that the word infinite fails to describe it? This is the realm of the multiverse, a concept that was once the playground of science fiction, but has now become a serious, mathematically grounded subject of study in theoretical physics. To understand the multiverse, we have to look at the very beginning, the moment of cosmic inflation. In the first trillionth of a second after the Big Bang, the universe expanded at a speed that defies imagination. It was a period of exponential growth that smoothed out the fabric of space. But according to the theory of eternal inflation, this process didn't just happen once and stop. Instead, inflation might be a permanent state of the megaverse. Imagine a vast, bubbling sea of energy. In this sea, bubbles are constantly forming. Each bubble is a universe. Our universe is simply one of these bubbles where inflation stopped, allowing stars, galaxies, and life to form. But outside our bubble, the sea continues to expand, and new bubbles are being born every second, each with its own laws of physics, its own version of gravity, and perhaps its own version of you. This leads us to the haunting beauty of string theory. For decades, physicists have struggled to find a theory of everything a single equation that can unite the massive gravity of Einstein's relativity with the chaotic subatomic world of quantum mechanics. String theory suggests that everything in the universe, from the smallest electron to the largest galaxy, is made of tiny, vibrating strings of energy. Just as a guitar string can produce different notes depending on how it vibrates, these cosmic strings produce different particles depending on their frequency. But for the math of string theory to work, the universe cannot have only 3 dimensions of space and 1 of time. It requires at least 10 or 11 dimensions. Where are these extra dimensions? Scientists suggest they are curled up so tightly that we cannot see or feel them, like the threads of a carpet that appear flat from a distance. But these hidden dimensions are where the true complexity of reality lies. If these strings exist, then the Boötes Void isn't just empty space. It is a region where the vibrations of reality follow a different harmony. It suggests that our universe is just a membrane or a brain floating in a higher dimensional space. Occasionally, these membranes might collide, creating a new Big Bang and birthing a new universe. In this view, our cosmos is part of a giant, multidimensional fabric, an endless cycle of birth and death that makes our 13 billion year history look like a mere heartbeat. Consider the existential implications of this. In an infinite multiverse, every possibility that can happen must happen. There is a universe where the Boötes Void never formed. There is a universe where the James Webb Telescope found exactly what it expected. There is a universe where the stars will never go out. But more importantly, it suggests that our search for knowledge is not just a human endeavor, is a cosmic one. If there are infinite versions of reality, then the footprint of knowledge we leave behind is part of a much larger, eternal story. We are not just observing the universe, we are one of the ways the multiverse explores its own infinite potential. But why does this matter to us, sitting here on our small planet? It matters because it changes the definition of home. If we are part of a multiverse, then the limits of our observable universe, the 93 billion light-years we can see, are just a tiny fraction of the whole. It means that the silence we hear from the stars is not a sign of emptiness, but a sign of our own limited senses. We are like ants, living on a single leaf in a forest that stretches forever. We can smell the leaf, we can feel the rain, but we have no concept of the trees, the mountains, or the ocean beyond. The multiverse theory is the ultimate reminder that no matter how much we learn, there will always be more to discover. The dark isn't something to fear. It is the canvas upon which the infinite is painted. As we look back at the great nothing of Boötes, we can now see it with new eyes. Perhaps it isn't a hole in our universe at all. Perhaps it is a place where the fabric of our reality is thin, a window into the higher dimensions that string theory predicts. Perhaps the reason the galaxies there are so few and so strange is that they are being influenced by the gravity of a neighboring universe, pulling at them from across the multidimensional void. We are living in a time where the line between science and wonder has blurred. The more we use our instruments to measure the real world, the more we find ourselves staring into the face of the impossible. The journey of the footprint teaches space is not just about facts and figures. It is about the feeling of looking up at the night sky and realizing that you are connected to everything. You are made of the same vibrating strings as the furthest galaxy in the multiverse. You are pushed by the same dark energy that is expanding the voids. You are part of a grand, eternal symphony that has no beginning and no end. The silence of space is not a vacuum. It is a hum of infinite frequencies, waiting for us to find the right way to listen. We have traveled through the hollow silence of the Boötes Void, stood on the edge of the heat death of the universe, and peered into the shimmering, multidimensional fabric of the multiverse. We have seen the ghosts of dark matter and the relentless pressure of dark energy. But as we reach the end of our journey, we must confront the most profound mystery of all. It is a mystery that does not sit in a distant galaxy or hide behind a black hole's event horizon. It is a mystery that is happening right now, inside your own mind. It is the mystery of the observer. In the world of quantum mechanics, the very foundation of our reality, there is a principle that continues to baffle the greatest minds in science: the observer effect. It suggests that at the subatomic level, particles do not have a definite state until they are measured. They exist in a haze of probability, a ghost-like state of being, everywhere and nowhere at once. It is only when an observer of consciousness looks at them that they collapse into a single, solid reality. This leads to a staggering, almost spiritual question. Does the universe require a witness to truly exist? If a star explodes in a void where no one can see it and no instrument can measure it, does it truly happen in the way we understand happening? Consider the vastness of the Boötes Void once again. For hundreds of millions of years, those 60 lonely galaxies drifted in the dark, unobserved and unknown. They were mathematical possibilities, floating in the deep. But the moment humanity pointed a telescope toward that patch of sky, those galaxies became real to us. We gave them a name. We measured their light. We integrated them into our story. We are the bridge between the cold, unfeeling laws of physics and the vibrant, meaningful reality we call home. Without a mind to perceive the beauty of a nebula or the terrifying scale of a black hole, the universe is just a collection of equations, a silent machine grinding away in the dark. This is the true power of your footprint. You are not just a passive spectator in a cosmic theater. You are a participant. Your curiosity, your questions, and your search for meaning are what give the universe its color and its soul. We are the eyes of the cosmos. We are the atoms of ancient dying stars that have, through billions of years of trial and error, developed the ability to think, to feel, and to wonder. When you look up at the night sky, you are not just looking at distant balls of gas. You are looking at your own ancestors. You are looking at the furnace that forged the carbon in your DNA and the iron in your blood. You are a way for the universe to know itself. Think about the sheer impossibility of your existence. For you to be sitting here, listening to these words, a billion-year-long chain of events had to go perfectly right. A star had to explode at just the right distance to seed our solar system with heavy elements. A planet had to form in the Goldilocks zone, where water could remain liquid. A massive moon had to stabilize our orbit. Life had to survive 5 mass extinctions. And through it all, against every cosmic odds, the flame of consciousness was passed down, generation after generation, until it reached you. You are the result of a 13-pointed billion-rolled success story. You are the universe's greatest masterpiece. And yet, we know that this masterpiece is temporary. We have seen the math of the heat death. We know that the stars will fade and the voids will grow. But does that make the present any less significant? On the contrary, the fact that the light is finite is exactly what makes it precious. A diamond is valuable because it is rare. A life is valuable because it is brief. We are living in the cosmic noon, a fleeting window of time where the universe is bright enough and warm enough for us to exist and to learn. We are the poets of a dying empire, tasked with recording the beauty of the stars before they vanish into the night. The footprint teaches space is more than just a name for a channel. It is a philosophy. It is the belief that every piece of knowledge we gain is a victory over the darkness. Every time we understand a new law of physics, every time we map a new exoplanet, every time we share a moment of wonder about the scale of the Boötes Void, we are leaving a mark that the entropy of the universe cannot immediately erase. We are building a library of light in the middle of a gathering storm. We are the architects of meaning in a world of chaos. As we conclude this long journey through the unknown, I want you to take a deep breath and feel the weight of the air in your lungs. That air was once the heart of a star. Feel the ground beneath your feet. That ground was once part of a protoplanetary disk swirling around a young violent sun. You are not in the universe. You are the universe. You are a localized expression of the infinite, trying to understand where you came from and where you are going. And while the answers may be hidden in the deep voids or buried in the math of the multiverse, the search itself is what defines us. Do not be afraid of the silence of the stars. Do not be intimidated by the scale of the great nothing. The void is not a lack of life. It is a space for potential. The dark is not an enemy. It is the canvas that allows the light to shine. As long as there is a single mind looking upward, as long as there is a single heart that beats with the rhythm of curiosity, the universe is not truly empty. It is full of us. It is full of you. So, as the lights of our own story continue to burn, let us make them count. Let us keep searching, keep questioning, and keep leaving our footprints across the cosmos. The journey does not end here. It merely begins a new chapter. The stars are waiting, the voids are calling, and the mysteries are as infinite as the space between them. If you have stayed with us through this hour of darkness and light, you are now part of a global community of observers. You are a guardian of the cosmic flame. If you felt a spark of wonder, if you felt the chill of the void and the warmth of discovery, I ask you now to leave your mark. Subscribe to Footprint Teaches Space and join us on this eternal voyage. Your support is what allows us to keep peering into the dark, to to keep challenging the silence, and to keep bringing the secrets of the universe into the light. Before you leave the silence of this video and return to the noise of the world, take one last moment to reflect. In the comments below, share your own footprint. What is the one truth about space that changed the way you see your life? What is the one mystery that makes you feel alive? The universe is vast, and we are small, but together, our light is blinding. Thank you for traveling with us. Thank you for being the observer the universe needs. Stay curious, stay bold, and never stop looking up, until our paths cross again in the next corner of the cosmos. This was Footprint Teaches Space. Good night, fellow travelers.